This is what our physical world looks like. At first glance, everything is fine. But if you look closely, you will notice that it looks very implausible. It should look different, like this. If you look at buildings going into the distance, you will notice that they are located along lines. These lines converge at one point. This is called linear perspective. Linear perspective is a bug of space. It is the most noticeable error in the source code of our universe. Every complex program has glitches. If we live in the matrix, we must sometimes encounter them. And one of them concerns space. Instead of linear, we should see exponential perspective. Angular size is the apparent size of an object, which depends on the distance. The further an object is from us, the smaller it seems. The apparent angular size of an object changes according to the formula. A equals 2 arctangents s divided by 2l. Where es is the size of the object, l is the distance to it. The essence of this formula is that as an object moves away, its apparent size decreases. But it does not decrease linearly, but according to a tangential function. Or, to be more precise, it changes exponentially. That is, as the distance increases, the apparent angular size of the object decreases quickly at first, then more slowly, then very slowly. For example, if a car moves 100 meters away from you, it will decrease very quickly and very strongly. And when it moves a kilometer, its angular size will decrease gradually. And if the moon moves 1 kilometer away from you, its angular size will not change, because it is very far away. The rangefinder scale in optical sights is also an exponential function. You don't have to be a mathematician to understand that nearby objects decrease in size faster as they move away, while distant objects decrease more slowly. This is confirmed by what we see with our own eyes every day. If you put a row of identical objects at the same distance, they will decrease in size as they move away. The near ones will decrease faster, the far ones slower. Exponentially. Let's look at the sleepers. They decrease linearly. How can this be? Maybe our eyes are deceiving us, and the brain is drawing a linear decrease instead of a real exponential one? But no. The photographs show the same thing. What's the matter? It's simple. This is a perspective error, the most noticeable glitch of our matrix associated with space. It is not difficult to guess how it appeared. First, the universe was created. There are no straight lines in nature. There are no large numbers of identical objects located in a straight line. There are no even edges, correct rectangles. Therefore, it did not even occur to the developers to develop an exponential perspective. And when humanity began to build even houses this bug suddenly became noticeable. Another spatial error is associated with it. The farthest objects are compressed into a point for us, even if they are very large. And then they disappear completely. This cannot be because their linear dimensions do not change. As they move away, they should decrease, but up to a certain limit. Exponential decrease will slow down until it stops completely. The exponential never crosses the axis. No matter how far away an object is from us, the light from its edges will never be compressed into a point. In the extreme case, it will come in parallel, from each edge. Moreover, the further the object is from us, the darker it should be. As a result of this error, we see, for example, how the sun's rays noticeably diverge. But they cannot diverge. From such a large distance at which the sun is located, the rays from it come strictly parallel. Why did not the engineers fix such a noticeable glitch? There may be several options. They may not have access to the code that determines the very foundations of our universe. Or humanity is too insignificant. And the most likely assumption is that this is not necessary, because humanity will soon cease to exist. So, looking at the railway, one can conclude about the imminent demise of humanity. Why don't we notice the obvious? It's simple. We look at the world as the only physical reality. If we look at it as the matrix, we'll see many more of these glitches. And it would be even better to learn to look at the physical world as the only reality, the matrix, yourself, the multiverse. At the same time,